Hi everyone, I'm Daniela Petruzalek, and I'm a software engineer at GoCardless, and also a Google developer expert in Google Cloud. And today I'm here to talk about actually a side project of mine that's called Pac Man for Scratch, or actually I just call Pac Go because it's Pac Man in the Go programming language. And you may be wondering why I'm talking about a game in a DevOps meetup. But actually, this game kind of doubles as a Go programming language tutorial. And this was designed back when I was in Brazil. Actually, I'm in London for a bit more than a couple months now. Just moved here. So anyway, this was designed to be like a workshop for the Women Who Go initiative, because we were seeking some interesting and fun ways to teach the Go programming language. And it was really successful, but in the end, since it was written in Portuguese and we were just learning about the language back then, it was not very idiomatic, so kind of the project maybe died a little bit for there. But then a couple months ago, I decided to resurrect it and do properly this time. So what I'm going to present here today is like the English version with proper idiomatic Go code. It's not perfect, but it's an open source project. So if you find mistakes, please pull requests and so on. OK, so before starting, the whole idea is that we're going to use the terminal as the screen for the game. It's very important to know a bit about terminal modes. So the terminal by default, when we use it, it's in what's called a cooked mode. And that means that for each keystroke we do, it's kind of the terminal pre-processed then before submitting it to the application. And that works that way because we want to intercept, for instance, Control-C, Control-Z, or some like arrow keys. Special keystrokes sometimes have special meanings. And cooked mode does that pre-processing for us. On the other end, we have the raw mode. That is exact opposite. It doesn't pre-process anything, just submit the keystrokes to the application, and the application must deal with it. And then finally, as you can imagine, in the middle ground, there's the C-break mode that does some of the pre-processing, not all. And we are aiming to use this mode because we want to handle the arrow keys, but not everything else. So basically, that's what we're going to use. We also be using some terminal magic, just to say. That are the NC escape sequences. You can imagine them as some kind of special commands that you write to standard output. They have like a special meaning for the terminal. For instance, you have an escape sequence to move the cursor to a different position, escape sequence to clear the screen, and so on. And usually they look like this. It's ESC, the escape character, like in hexadecimal 1B, plus the square bracket, and plus n number of bytes that, depending on which byte you submit, then you have a different command. OK, that's all my slides. Now the rest of this talk will be just code. But please bear with me. I have a bit less than 15 minutes to go through this. So this will be really fast-paced. But in the end, the idea is that someone is able to follow this tutorial by themselves. Or maybe if you want to hold like a workshop or something, then you usually would like to reserve like a couple hours, a bit more, maybe 3. Depends on the depth of the concepts you want to go. Anyway, the tutorial starts with the step 0. And we are doing some really old school game programming here. So basically we have like some initial setup code. And then we have like a game loop that's basically an infinite loop that you can either terminate the game gracefully, or the player dies, or the player wins, and then you interrupt the game. So now the first step is just we have this comments that act as placeholders for the code that has to come. And we're just printing hello and breaking the loop, so it should work. I have these steps pre-compiled, so we don't have to wait for the build. OK, hello world, we're live. Then let's go. Let's do some game programming. So the first step, it's important to mention that each step has its own README. And you can skip the steps because the code is like copied and pasted with the increments from each step, so you never get lost, basically. And the README has all the explanation. OK, step 1, we want to load the maze. So basically, we're just creating a function to load the file. We are going to read this as a text and append it to a maze that's a slice of strings. That's our internal representation of the maze. We also have this print screen function that for now it just loops through the array and prints line by line. And we start replacing some of the placeholders with the actual code. So we have load maze. In the game loop, we have print screen. And then we still have the break condition just for us to not do this forever. So step 1 prints the maze. And this is our representation of the maze. Not very exciting now, but this is the proper map for Pac Man. To be known, the hash signs are the wall, the dots are the dots. P is the player, G are the ghosts, and we have X for the power-up pills. We are not going to implement this today, but I leave this as an exercise for you, maybe submitting a pull request. OK, next step, we're starting to do some console magic now with escape sequence. We've added some helper functions, clear screen, move cursor. And now this is very important for animation. We are adding the clear screen step in the print function. So we can give this illusion of animation, like clearing the screen, printing a different frame. We also, sorry, a bit of delay, added this read input function that now we are just concerned about reading the escape key. That will be our graceful exit key. And we have this initialization code. It's a good opportunity to teach for people who are not familiar with Go the meaning of the init function. This is actually called before main. And we have a cleanup function that's at the very beginning is deferred to be run at the end of the program to restore the terminal mode to the traditional cooked mode. And we replace the process input with actually reading input. And now we don't have that permanent break. We have a conditional break on the escape key. So, OK, step 2. Apparently nothing has changed, but if I press anything, it basically, where's my ESC? Here. OK, if I press ESC, it is exit and restores the terminal. That's really important. If I press Ctrl-C to break it, the defer function would not be triggered, so I will be stuck in the C break mode. So that may happen if you try at home with Ctrl-C. OK. So far, we're still setting the ground. Now we're starting to do some real animation. And we need a structure to hold the player data. So basically, right now, we want to keep track of the row and column of the player is located. We're also modifying the load function. So we can have, when we find the P in the map, we initialize the player position. And the really important part, we also are modifying the print screen function. So now we are not interested in just printing the lines in the map, but we actually want to control what we print because we want to be able to move the cursor and print the player at a given position, their current position, basically. And here is the input function. Now we are processing like each arrow key as a proper coordinate. And one interesting part here is that I have a buffer of 100 bytes, but I'm only reading the first 3. And you may think at first that this is a bug. This is not a bug. This is on purpose, because you don't actually want to enqueue key presses, because you want your game to be responsive. Imagine that you have like 100 left arrow keys on the buffer, and then suddenly you want to move up. So you're not interested in being precise this way. You want speed. So basically, that's why we drop the other characters. We also have this make move function that basically it tries to do a movement. And the way it works is I have like a position in the grid, and I have a direction. And it will give that nice effect of Pac Man that if you go to the end of the map, the character appears on the other end, or up and down and so on. And also, the trick here is that if I hit a wall, it basically restores the original position and do nothing. And I'm using a nice trick here that's the named return parameters, so I don't need to specify the return. I'm just like, it's just basically the idea. Remember that this is a tutorial, so it's to explore different features and show what Go is capable of. Okay, finally, the move player function just calls make move with the player position. And we have the process movement. Now we have this function to move the player. Okay, just sorry, step 3. Okay, now we are not seeing anything else because there's a bit of delay, but I modified the print screen function just to print like what we are interested in. For now, it's just the player. Okay. Time to add some more stuff to the map. So next step is to add the ghosts. And the ghosts work basically the same. We have like a structure to hold their position, but instead of like just having one player, we have an array of ghosts and a pointer to ghosts because I want to update their positions in the array. And if you look at the first code was harder. This is basically we just add a new condition that processes G's and append the ghosts to the array. Now, since ghosts should move by themselves, we don't need an input function, but we need some kind of like algorithm to process the movement for the ghosts. And we are using some really rocket science algorithm here that basically it's called draw direction and sorts a random number between 0 and 3 and assigns a given direction to one of these numbers. Basically, we're just like randomly go up and okay, I can't go up because there's a wall, then you just stay there. It works fairly well. Then we add this move ghost to the process movement section, and we have like step. Sorry, I forgot which step. This is 4. Okay, we are starting to see some stuff happening. There's an obvious problem that the ghosts only move when I move my player, but I will solve this in a few seconds. But let's move on. For completeness, a game must have like some game win and game over conditions. So here, what we are doing is to add the dots to the game again. And basically, we're counting the number of dots we have. And every time we have the player hits a dot, we remove it from the map and decrement that counter. So when it reaches 0, we know that we have reached out to like a game win condition, and we have to modify the player code. So here the line isn't showing completely, but we have to use this nice trick with slicing the string, because we are using strings as a representation and strings are immutable in Go. So basically we're slicing until the dot, then replacing a space in the place of the dot, and then getting the rest of the string. So it's really tricky, but does the job. And also we have the game over condition, and the collision code is really simple. We just scan through every ghost and see if it matches the player position, and then he dies. And we're not implementing several lives in this case, but should be trivial to do. Okay, step 5. So for obvious reasons, I removed all the dots and left just 3. But you should see that the game ends. It kind of it's a bit disappointing because it ends on the frame before the end of the game. But okay, we'll fix that in a second. Now we have like all the things in place we need to make a game, but it's really boring that the ghosts only move when we move. And if you only had a resource in Go that would make things asynchronous and make it really easy, yeah, luckily we do. And we can use actually channels and goroutines to do that. So instead of having that blocking step of input in the main loop, we spawn a goroutine that writes to a channel. And then we have this non-blocking read of the channel to get our input. So now the input logic is not in the main process, so we're not blocking. Hence, we need to add a delay. In this case, we're adding a delay of 200 milliseconds, or we are basically have a game that runs at 5 frames per second. And okay, let's see how does that work. And now it moves by themselves, and I can move the player independently. Okay, it's starting to look like a game, but I've promised emojis. So final step in this tutorial is like to have a config struct, and it's a JSON file with mappings between each of the sprites and objects in the game to a given emoji of your preference. And in the main file, I added this config struct and a load config function that basically takes this JSON file and maps to that struct. And of course, the print screen, now instead of printing the same character, prints the sprite of the given object. And there's this important step that I had to make, because emojis they are usually 2 bytes length, and usually I was using ASCII before, and they were just 1 byte. So I'm kind of doing some corrections because I'm mixing those two. So I'm always using 2 bytes per column, so we don't have like bugs in the drawing of the map. And okay, so that's. I also added that sequence of that animation, but let's just look at the final one. Then we have now working properly with emojis, and if you go to the ghost, then catch me. Oh, yay! Finally, it died. It became a skull. Anyway. I know this was really fast. The idea is just to give you another tool if you want to learn Go or teach someone Go. And please contribute to the project. These are just, I couldn't explore a lot because of the time constraints. But I'll be around. Come talk to me. And thank you very much.